Hello, everyone. I'm Ali. I'm one of the Lilypad co-founders, and I'm excited to be here today as open data and infrastructure aren't just an interesting and kind of topical field of study and growth, but to me, how we build or don't build these pieces of technology is going to be absolutely essential to ensuring we provide equitable access to technology and the web in future years, and it's a major driver behind the Lilypad project as well. So what is this lily pad thing besides a lovely pond plant Monet used to paint? Well, let's go back to basics a little bit. If we think about what the modern web stat looks like, it's all about data. Something I probably don't need to tell any one of you here at an open data summit. But we either want to move data around, store data, or make data useful. And these three components, networking, storage, and compute, form the basis of pretty much everything we do in today's connected era. So far, though, compute has kind of been a missing piece of the decentralized infrastructure story, with a few kind of experimental exceptions, and that's likely for a few reasons. There's a lot of complexities involved in building a fully distributed compute network. And the research is really bleeding edge still. And secondly, as a space, we probably just weren't quite ready yet. There were more pressing problems to solve: internet scale storage, friendlier UX, or scaling solutions as well. Um, Thirdly, the exponential explosion of AI and ML into the mainstream has kind of put the focus back in onto the hardware required for AI workloads. And so the demand for compute is currently incredibly high. In fact, there's currently a global shortage of GPUs to perform compute jobs like training and running AI models. And this is something that decentralized physical infrastructure networks and blockchains are uniquely capable of providing and incentivizing at scale. So this is really why I think the next frontier for computing in Web3 is at this data layer. To build these truly kind of decentralized applications that can run at internet scale and reach mainstream adoption requires more efficient off-chain computation that isn't just a centralized backend though. And this is where we can start to both kind of make data truly useful as well as showcase the value of distributed networks to new users, and even to the famous next billion that we're all looking to onboard here in Web3. And this is definitely one of the reasons we're seeing more developers and teams in the space start to tackle this part of the infrastructure stack, and why I've dubbed it the now frontier of Web3 as well. Because in order to create these kind of internet scale, decentralized applications we want to see breakthrough to a mainstream audience, we're going to need truly internet scale, permissionless compute platforms. So this is the space and future we're hoping the Lilypad network can play a big part in building. So with Lilypad, we're aiming to provide this permissionless distributed compute network that enables these internet scale computing jobs and also unlocking idle compute power. So at its most basic, Lilypad is really an efficient peer-to-peer marketplace for compute jobs. In practical terms, Lilypad enables folks running hardware to join the network and be paid for contributing their hardware to it, while enabling developers and consumers to connect with the network to run all sorts of arbitrary compute tasks as jobs. And that includes our current focus of AI inference jobs like Stable Diffusion and open source LLMs, as well as ML training jobs like LoRa and Minstrel. And we want to make sure that that is easy for people to use as well. So you shouldn't need a degree in AI to access state-of-the-art open source models for your next app idea. In fact, it should be as easy as any web UI out there makes it. Equally, you shouldn't need to pay a fortune to keep a cloud GPU running so that you don't lose access to it for the training job you need to run once a week. So sure, you can run some powerful compute jobs, but you can already do that with AWS and APIs. Why bother with this whole distributed network thing? Well, my friend, there's both practical and ideological reasons for distributed compute platforms. Allow me to fill you in. Firstly, I happen to agree with this great Tim Berners-Lee quote in that the access we have to the internet, as well as the restraints we have on using it, depending on like our geography, our country of residence, our resources, these are incredibly important parts of what defines our modern day human experience and our, I would go as far as to say, human rights. And it's why I believe it's incredibly important that we're making sure that any tech infrastructure we're building, as I said earlier in the piece, enables and even enforces these values of fairness and of trustlessness and openness that we need, and that really pins the a real goal, underpins the real goal for tech and scientific breakthroughs, and that is that of improving the human condition. If I can take a little bit of liberty here with Tim's quote, I think it's never been more important that we're building open infrastructure paths than it is now, with AI and ML really poised to massively disrupt how we work, live, and play. Currently, though, AI breakthroughs are very much situated with large central players that have access to vast amounts of compute power and data sets. Both the models and our access to them are either a black box, they're rate limited, or they have other questions on their origin. To me, though, in the same way that one company really shouldn't control access to scientific breakthroughs, central entities should not control access to AI advancements or the data sets they're trained on, and shouldn't be able to decide on the regulations and rules around that. In fact, we should all be stakeholders in its future, and we should all have the capability to check the data and algorithms for biases or security issues, and to have a say in that collective future direction. And Peter Wang does an amazing job of explaining this in this talk up here as well, that I would recommend you check out. What's also interesting to me, though, is that according to this leaked Google article, and I loved reading this, it's clear that open source AI and ML is already outcompeting the centralized versions. And that's because they're able to define use cases and to fine tune more easily on way less data points. So they're also able to target where the common good lies. So much like Arduino revolutionized hardware and IoT development by giving hobbyists access, giving people and developers the tools for AI and access to compute power really speeds up solutionizing and innovation in the space as well. They know where the problems are, they just need the tools to solve them. So this brings up a problem which Elon Musk has so eloquently described here, though, and that's access to GPUs. And it's a problem that even OpenAPI is experiencing at the moment. So access to GPUs at a reasonable price is a key issue for open source AI and ML, and also for new market entrants to be competitive in the open market. GPUs are everywhere, though. We just aren't allocating them to the market efficiently. And this is not surprising given the centralized nature of much of the world's infrastructure, which by this summit's introduction was quoted as 90%. And fun fact, I immediately signed up when I read the intro sentence for this summit. So it's a big problem and it's one we're looking to solve. But anyway, this is where permissionless distributed networks really shine. That is in creating open peer-to-peer networks. It's their ability to create these efficient marketplaces with open participation and fair incentive structures. So not unlike the way that Uber disrupted the taxi industry back in the day with a peer-to-peer model, I would go as far to say either. This accessible hardware via an efficient open peer-to-peer marketplace is one of the practical reasons and benefits for a distributed network as well. So Lilypad is also really great for efficiency of pricing and distribution too. Currently, the market dynamics currently we're largely in a vertically integrated oligopoly, and compute costs are prohibitively high for new entrants in AI because of this. Instead, Lilypad enables these coordination layers to match the demand for CPU and GPU with supply, and that brings in better market dynamics and therefore cheaper prices. So, just to recap, in both practical and philosophical terms, distributed compute networks like Lilypad can really provide a host of benefits for participants on all sides of the market. Let's dig into how we're actually making all this happen, though, and how far along we are too. So the tech details. We're currently at Lilypad Aurora testnet. We are live and running. So that was a big thing to get to. So we're really happy to be there as well. So Lilypad combines this off-chain compute implementation details while providing on-chain coordination and verification. It's built in Go and Solidity, and it's currently running on IPC, which is a super fast scaling L2 out of Protocol Labs. It uses its own ERC20 token, which we've dubbed LP, to pay for services and gas, and it's fully EVM compatible. So in the future, we'll probably more than likely roll it out to other EVM based chains and become multi-chain as well. If we have a look at the tech stack, the Lilypad kind of layers stack, if we start at the bottom, we've got the code libraries. This is the underlying SD code of the network. On top of that is the smart contracts. This is the on-chain part of our network and what gives us these kind of on-chain guarantees and verifiability, or partly the verifiability that we're looking for. So these smart contracts handle deal agreements, dispute resolution, and job and escrow payments, and it's where all the deal information is stored. Thirdly, we have the Lilypad network itself. Most of this happens off-chain. This is where all the services live. It's where jobs are discussed, mediated, agreed on, and run. And then we have recently released this kind of abstraction value layer called Lilypad AI Studio. And I'll show you a little bit of this a bit later. But this is a web interface for running Lilypad AI jobs, and it provides this seamless Web 2 experience for users. So making it really easy for people to interact and get to know this, get to know Lilypad, really. So I was talking a little bit before about job verification. How do we know that one of these peers on the network has actually run the job correctly and is returning the correct result? Well, in order to make sure that jobs are performed as specified in the network, Lilypad has opted for a game theory approach to this compute verification, and it uses optimistic reproducibility to incentivize good actors and discourage cheating and collusion in the network. Basically, you can kind of think of it like a train ticket inspector. If the price of a ticket is reasonable, and if the chances of a ticket inspector coming along are high enough, then you will probably do the right thing and buy a ticket. So this is kind of, it's a bit more complicated than that, but you'll probably do the right thing and buy a ticket if those conditions are correct. So we'll get back the right answer from this. You can also challenge that statement as well. So there's a few more moving parts in that, but that's the basic analogy that works for me. Okay, so in order to verify jobs, though, they currently need to have one outcome. So all jobs on the network are currently required to be deterministic to enable this verification, although we're moving to a non-deterministic version of this as well. So to achieve this objective, while also maintaining the flexibility that we want for people to be able to create and run their own jobs in the network, Lilypad employs a module system. So a module is just the specification for a compute job to run on Lilypad, and it's basically just a GitHub repo. So there's currently several modules available to use that we've created, the community has also created as well. We've had several contributed by community members. Some of these modules are an LLM fast chat. There's LoRa fine tuning, which allows you to tune a new model based on inputs from an IPFS CIT. There's of course stable diffusion, text to image, and you can check out the docs if you want to build your own module to run on Lilypad as well. All right, now that I've kind of like tempted you with tech, let me show you how it actually operates. So user details. Where's my AI, please? So users and developers have kind of access to all these modules via three different methods. You can use the Lilypad CLI, so via your terminal on your computer. You can use smart contracts, so you could integrate this in your decentralized apps already and via a smart contract. Or you could use the Lilypad AI Studio, which I spoke a little bit about before, which is a web interface and is hosted on lilypad.tech. I'm going to get you started with the CLI version, or this is also relevant to the smart contract version as well. So if you want to get set up, all you need to do is add our network. It's currently called the Lilypad Aurora network. Add that to your MetaMask wallet. You can then go to our faucet and grab both some ETH to pay for gas and LP to stake and pay for jobs on the network. You just need to install. It's a one-line command to install either with the Go toolchain or with the official binary. Just one line of code into your terminal, off you go. And then you just need to put in your wallet private key because you need to be able to, the terminal needs to know what you're paying for things with. So you put your wallet private key in there and that's it. You're done with setup. Now you can try it out. So this is our basic hello world, our how do you do, if you will. So you can give this a go by running this command directly into your terminal or with the CLI. And you should get, as an output, you'll either get an IPFS CID, but it's also downloaded locally to your local drive. And there's a how-to video on our YouTube as well if you want to check that out on how to do that. And you'll get this lovely cow picture, so you'll know it's working. Now, it's a bit of fun, but I'm not sure how useful it is. So you can also do, obviously, more than that. Here's an example of running an SDXL, so text to image stable diffusion with the CLI as well, an astronaut riding on a unicorn. Now you can also use these in smart contracts. So have a look at our docs for how to properly implement this. But once you do, you'll just be able to simply call a function in your smart contract and the job will be returned as an IPFS CID. So something like we've got here. I've mentioned this a couple of times now. This is Lilypad AI Studio. Super simple to use. Jump on the web, lilypad.tech. You don't need a wallet. It's a social sign-in. You pay with Stripe, although, of course, we're on testnet at the moment, so everything is currently completely free, and it'll have all of your latest favorite models in here to use and play around with, like Mistral 7B, which I'm looking forward to, and Stable Diffusion. So if you want to hear more, like if you want to run your own node or you want to make your own module, please go and check out our docs. They're at docs.lilypad.tech. All the information hopefully is in there. But if it's not, please get in touch with us. You can find us on our Slack. We're at bit.ly, Backyard Project Slack. We're on Twitter. We have a blog, dogs. Obviously, we have a GitHub for all this code. It's completely open source at the moment. So feel free to check that out. Or otherwise come and see me or talk to me. I'm Developer Ali on Twitter, or I'm also in the Slack. And I want to just thank everyone for having me here today. I really appreciate what you're doing here. And please get in touch. I'll talk soon.